Welcome everyone. Today we're going to start our conversation on trigonometry, and we're going to start by looking at some basic ratios when it comes to trigonometry. So our learning target for today is we're going to understand how trigonometric functions relate to right triangles, and we're going to solve some problems involving those right triangles. So in order to be successful on understanding how trigonometric functions work and how they relate, we need to be able to identify the hypotenuse, the adjacent side, and the opposite side of any angle in a right triangle. We also need to determine the three basic trigonometric ratios for a given angle in a right triangle. And then in the next lesson, we're actually going to then investigate how to find the missing lengths and angles of right triangles. So that one will come in video number 2. So let's talk about trigonometry and what trigonometry means. So the definition of trigonometry is just the study of ratios of the sides of a triangle to an angle of a triangle. And if we look at the word trigonometry, by definition, trig is going to be a triangle, and metry is measurement. So we're looking for that measurement within a triangle. So let's say we had just a little triangle going on here, and I'm going to make this triangle a right triangle. And I know that it is a right triangle because that little square is telling me that this is a right angle. And we know that right angles are 90 degrees. So I'm just going to say that the length of this side is 3. And I'm going to go with this side down here as being 4. And this little guy over here, I'm going to say is 5. So with this being a right triangle, we hopefully can recall Pythagorean theorem. Pythagorean theorem is the sum of the square of the two smaller sides equals the square of the longer side, or the hypotenuse. So we actually could go through and do 3 squared plus 4 squared equals 5 squared. And that'll prove to us that this is truly a right triangle. So that talks about all of the sides of a right triangle. But when it comes to trigonometry, there's a ratio that these sides have. And when it comes to those ratios are dependent upon the angles in which we are looking at. So for our purpose, we're going to focus on 3 core functions, 3 core trigonometric functions. And the 3 that we're going to focus on is going to be sine, cosine, and I'm going to make this assumption that in geometry, we all started that conversation of sine, cosine, and tangent. And we used to use the mnemonic, or we still use the mnemonic SOHCAHTOA, right? SOHCAHTOA. So some people write it out straight like this. My personal preference is I like to write it as SOHCAHTOA. So it doesn't matter which one you pick. It's your personal choice. I like this one, and I'll tell you why. This mnemonic is ultimately telling us that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. When we write it this way, it actually kind of tells us that it's over. So this is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So that's just why I prefer that one, but personal preference by all means. So now our question is how does using these core trigonometric functions relate to this triangle that we're over here? So I always say that there's a relationship between angles and sides. And right now we see our 3 sides. This is where that SOHCAHTOA, or that sine, cosine, and tangent come in. When I'm talking about sine, cosine, tangent, or any of the trigonometric functions, I'm talking about it from an angle. So we need to kind of sit there and look back at our triangle, and we need to make a notation on one of our angles because we don't know what the measurement of one of our angles are. So I am just going to sit there and say, let's start by talking with this angle. So when it comes back to our function, opposite hypotenuse, adjacent hypotenuse, opposite adjacent, it's ultimately naming our sides. So off of our three sides, we need to figure out which one is adjacent, which one is opposite, and which one is the hypotenuse. And it all depends on what angle we are looking at. So we're looking at this angle theta. So from this angle, I need to make a connection between what sides are what. So I'm going to start by going straight across. I'm going to go to the opposite side of the triangle. And if I go to the opposite side of the triangle, this is going to be my opposite side, right? I know we learned when we started talking about right triangles when it comes to finding the hypotenuse. The hypotenuse is always across from that 90-degree angle. So this is my hypotenuse, right? It's also the longest side of any right triangle. And then my 4 is going to be my adjacent side. So from this angle, my theta, adjacent means next to. Well, it's touching it, but it can't be the adjacent because it's the hypotenuse. So my adjacent side is this one. So this is my adjacent side. So now we have enough information to where we actually can figure out our sine, cosine, and tangent of this angle theta. So when we write these, we're going to start off with sine, right? So sine of what angle? Theta, because that's the side that we're going from. And we know that sine is opposite over hypotenuse. So from theta, which one was my opposite? 3. Over my hypotenuse. Which one's my hypotenuse? 5. So sine of theta is 3 over 5. Let's see if we can do cosine of theta. So cosine of theta is adjacent over hypotenuse. So from my theta angle, what's my adjacent? 4. And what's my hypotenuse? 5. And finally, let's look at the tangent. So the tangent of theta equals, and we know tangent is opposite over adjacent. So from theta, opposite is 3 and adjacent is 4. So our ratio, a ratio is a fraction or a number over a number. We know it is going to be 3 over 4. So those are our 3 core trigonometric functions for this triangle. So it changes depending on what angle we're actually looking at. So I want to keep this triangle just the way that it is, right? I'm going to keep this same, whoops. Sometimes I can draw. We're just going to use our imagination, right? Look at this. Hey, I'm getting better and better with this little tool. Maybe. As soon as I think I am, I screw it up some more. All right, close enough. We're going to shade it in. So I'm going to sit with that same triangle. This had a side value of 3. The bottom piece had a value of 4. And my hypotenuse had a value of 5, right? And it's still that right triangle because I noted it with the little box in the corner, right? So on the original one, we made it where our angle that we were talking about was here, which was our theta. Well, I don't want to talk about that angle now, so I'm actually going to jump up here to this angle, and we're going to talk about that other angle. And I'm going to name it alpha. It's just another letter in the Greek alphabet, right? So I want to do the same thing that I did up above, but now I want to look at it from my angle alpha. So again, I need to figure out which side is what, right? So from my alpha, if I go to the opposite side of the triangle, that's going to be my opposite side. So this is my opposite. From my right angle, if I go opposite or the other side of the triangle from my right angle, that is always going to be my hypotenuse, which is also the longest side of my right triangle. And I need 3 is going to be my adjacent, right? Adjacent means next to. So that's the one that's going to be next to. That's not the hypotenuse. So this one is my adjacent. So now I can go through and do my sine, cosine, and tangent, but now I'm going to do it from alpha. And let's see if the answers are the same or different. So if I want to do sine alpha, sine is still opposite over hypotenuse. So from alpha, my opposite is 4 and my hypotenuse is 5. So I would have 4 over 5, right? If I do cosine of alpha, cosine is adjacent over hypotenuse. So for my alpha, my adjacent is 3 and my hypotenuse is 5. So I would have the ratio 3 over 5. And if I do tangent of alpha, tangent is opposite over adjacent. So from alpha, opposite is 4, and my adjacent is 3. So, whoop, where'd my 3 go? Over 3. There we go. And if I look, my sine of alpha and my sine of theta, these two are not the same value. They are different. Same thing with my cosine and same thing with my tangent. Granted, you can make a correlation that these are opposites and these are the reciprocal, but that's a different kind of conversation. We want you guys to understand that depending on what angle you're going from, you're going to get different answers. I want to spice it up and give you guys a real fancy problem. So let's give a nice little triangle here. We're going to go with the right triangle. I'm going to say this has a side of 2, this is a side of 6, and this is a side of 4 times the square root of 2. And I'm going to say theta is right here. And just for this one problem, I want us to figure out the tangent of alpha or theta, right? So I know that tangent, if I go off of my mnemonic, right? So, ka, to, right? So I'm doing opposite over adjacent. So if I need to go off of this angle. So I need to figure out my 3 sides. Oops. So if I start here, if I go to the opposite side, my 2 is going to be my opposite, right? If I go for my 90 degree, my 6 is going to be the hypotenuse. And that leaves this one as being my adjacent. And it's the adjacent because it's next to the angle that I'm talking about, but it's not the hypotenuse. So for my problem, to find the tangent of theta, opposite over adjacent, is going to give me 2 over 4 times the square root of 2. So this is a great start. We at least have the ratio set up correctly, but in mathematics, we don't like having those radicals in the denominator. So we need to figure out what we need to do in order to get rid of that radical, this guy, that square root of 2 out of the denominator. So we can actually multiply top and bottom by the square root of 2, right? So square root of 2 over square root of 2, which is no different than 1. We can multiply top and bottom by that to get rid of my square root. So I'm going to go times the square root of 2 over the square root of 2. So on top, multiplying fractions, we're just going to multiply straight across. 2 times the square root of 2 over 4 times the square root of 2 times the square root of 2. I'm going to write this out the long way, and I know many of you guys are getting very fluent with your math skills, and you can kind of skip a couple of these steps, but I'm just going to go through and do it the nice long way to show every step, right? So now I can simplify this down. My top is still going to stay 2 times the square root of 2, but on the bottom I have 4, and I can do radicals to radicals and reals to reals. So square root of 2 times square root of 2 is going to give me the square root of 4. Simplifying this down farther, on my top I still have 2 times the square root of 2. On the bottom I now have 4 times, I know that the square root of 4 is 2. Continuing to simplify it, 4 times the, whoops, I apologize. Let me get that off there real quick. I'm working ahead of myself. On top I have 2 times the square root of 2, and on the bottom 4 times 2 is 8. So now I can reduce this, but I still have to keep in mind it's always reals to reals and radicals to radicals. And with this little square root of 2 right here, I can't simplify him with anybody. The only thing I can do is I can look at my real numbers, and I can only simplify my real numbers down. So I can simplify this into square root of 2 over 4, right? I just divided it by 2. Right, 2 goes into there once, 2 goes into here 4. And then this is my final answer. Make sure if you need to, go back, watch the video again, take some notes, take it slow, pause it, rewind it. If you have any questions, you know how to get a hold of me. Talk to you later. Bye.